So, how's everybody doing out there? Well, welcome to day 23 of Corona Online School. So, I'm looking forward to seeing what kind of video solutions you guys have made to the problems, the fraction story problems. So, I can't wait to check out what you guys post today and stuff like that. So, otherwise, today we're moving on to the last topic in this unit, which is talking about the rational number system. So just to kind of refresh us at this point, so this is going to be the fourth number system that we've actually learned so far this semester. So remember, we started off in the beginning of the semester learning about the natural numbers, which was just the same thing as the counting numbers. And so we've got them listed there, 1, 2, 3, the whole way up. And then we took the counting numbers and we added 0. And then that gave us the whole numbers in this case. So 0, 1, 2, 3. And then we took the whole numbers and then threw in all the negatives to go along with it. And so that gave us the integers. And so finally, all the stuff that we've been working on so far this chapter has been fractions and stuff like that. And so this gives us our rational numbers in this case. So I formally define, what we mean by rational numbers. So, the rational numbers denoted Q consist of all possible ratios of integers. And so the bad thing is, like all the ways above, like we were able to write this in a nice set notation. So this one we can't obviously list them because there's so many different fractions. So the best that we can do for representing the set of rational numbers is saying it's Q is equal to the m over n, such that m is an element of the integers and n is an element of the integers minus 0. So remember, we're not allowed to have a 0 in the denominator. So I don't want to just say n's an element of z, because that would allow me to have a 0 in the denominator, which would be bad. So that's why I've got the z minus take away 0 in this case. All right. And so one other thing that we get that's unique to rational numbers compared to the integers is we're picking up a new property. And so this is what's called the multiplicative inverse of a number, which states that if r is equal to some a over b not equal to 0, then there's a unique rational number named r to the negative 1, which we denote as r inverse, is what we call that, which is equal to b over a, which for you guys that remember this is called the reciprocal of a over b, for which if you multiply r times r inverse, we get a over b times b over a, which we know in this case the b's and the a's will just cancel out, and so we just get 1. So again, this isn't something that we could have done in the integers, because if I tried to multiply something times 6 to give me 1, there's no integer that will actually do this. So that's why this property doesn't hold in the integers, but this property does hold in the rational numbers in this case. All right, so this is another property of rational numbers, and so it's what's called the kind of the density property of rational numbers. So in my little sentence I've got above here, so I've mentioned that, in the integers, if I said, find me an integer between 3 and 4, well, hopefully you'll say, well, there aren't any. There's no integers that live between 3 and 4, and that would be totally true. But the same thing's not true for rational numbers, which is kind of cool. So let's look at this example here. And what the goal is, we want to find at least one rational number between 2/3 and 3/4. So the way we actually go about doing this is, what we want to do is kind of make these guys have the same denominator. Now, in this case, you don't have to go for the least common denominator, and in some cases, if you do go for the least common denominator, you may not actually get the answer right away. So I would just recommend taking whatever the denominators for each of these guys are and multiplying the other fraction by that denominator. Now, in this case, this will actually be the least common denominator, but if it's not, don't worry about it. So like in this case, since our second fraction has a 4 as its denominator, we're going to multiply the first fraction top and bottom by 4 over 4. And then the second fraction we're going to take 3/4, and since the first fraction had 3 as its denominator, we're going to multiply top and bottom by 3. And if we're lucky, there's going to be a nice number in between them. And if there isn't, that's okay. I'll show you how to keep going and find the right answer. All right, so in this case, now just multiply straight across the top. 4 times 2 is 8. 4 times 3 is 12. Again, multiply across the top. 3 times 3 is 9. 4 times 3 is 12. And so notice in this case, there's still no obvious number in between 8 over 12 and 9 over 12. Other than if you use like a decimal, but we're not using decimals yet because technically we don't know what a decimal is. But so what we want to do is we want to keep going. And now all you have to do is, just kind of maintain that denominator being the same. So what I'm going to do is I'm going to multiply both numbers by the exact same thing, top and bottom. So I'm just going to kind of multiply both top and bottom by 2. You could have done 3, 5, whatever you wanted. I mean, you could have done as many of these guys as you wanted. And so now, if I multiply across the top, I get 16 over 24, and I get 18 over 24. So now if I look at these guys side by side, I can clearly see that a number in between these guys would be 17 over 24. But in fact, it turns out that not only is there one number, we could do this all day long, and there's actually an infinite number of rational numbers that live between 2/3 and 3/4. It seems pretty hard to believe, but we could keep doing this same trick over and over and over and over and over again, and continuing to actually find more and more numbers that live in between them. So that's kind of the cool thing. So like, for example, if I multiply both of these by 2 again, so now in this case I get 32 over 48, and I get 36 over 48. So now if I list them out, I can see that now 33 over 48 lives in between, 34 over 48, whoops, 35 over 48. And so again, if I keep doing this, I'm going to keep making more and more and more and more fractions and stuff like that, to the point where, again, we can spend our whole life doing it. So that because again, there's an infinite number of these numbers that are out there. All right, so with that in mind, you guys work on practice 1, which is doing the exact same thing, trying to find a rational number between the two rational numbers that are given. So again, if you don't find one on your first attempt, just keep increasing both fractions by the same amount until you find that there's some different, some numbers in between them. So when you're done that, unpause the video, come back, and then we're going to talk about computations with rational numbers, which I didn't spell right here. All right, is everybody doing okay with these guys? So in this case, up until this point, all we were really focused on was trying to find models of how to do additions, subtractions, multiplications, and divisions. So we did do some of them, just plain Jane practice. So in this section, this is all just plain old practice problems. So no models or anything are necessary, just add or subtract, multiply or divide, whatever technique you need to use to do them. So I'm going to leave these as practice for you guys just to see how you do. So let me know if you get stuck or if you need me to walk you through some of them, because I can make a quick video or whatever to show you. But otherwise, I'm going to leave practice 2 for you guys to work on. Same thing for practice 3. These are all just kind of, just no models, just plain old multiplications and divisions and stuff. So I just want to see how well you can do. So if you do get stuck, let me know. So at this point, pause the video, work on practice 3 and 4, and then when you're done, come back and we're going to talk about how to solve some equations using rational numbers. All right, everybody doing okay so far? So again, if you get stuck on any of those, definitely let me know so I can write up some more solutions for you or make a video, whatever you guys need. So in this case, what we're going to do is we're going to be working on solving equations involving rational numbers. So the main thing that we need, and what actually allows us to do that, are these two properties here. So we've got our additive inverse property and our multiplicative inverse property. So our additive inverse property basically just allows us to, if you're given some number a over b, there's another number, namely negative a over b, so that if you add those two guys together, it'll equal 0. So like in this problem above, x plus 1/2 equals 5 over 2, the goal is what we're trying to do is we're trying to get x by itself. So the way I need to get x by itself is I need to get rid of that 1/2. So again, so using this additive inverse property, what it allows me to do is take that x plus 1/2 and do a minus 1/2. But again, I can't do one thing to one side of the equation without doing the exact same thing to the other side. And so by this additive inverse property, the 1/2 plus negative 1/2 is just going to cancel out, which is what we wanted. And that's going to leave me an x. And in this case, I want to take 5/2 minus 1/2. So since they've got the same denominator, I'm just going to subtract 5 minus 1, which is 4 over 2, which simplifies down to x equals 2. So that's what you would do if you had, an x plus or an x minus. You would just kind of do the opposite, either subtract the number from both sides or add the number from both sides if it happened to be a negative. So same thing is true if we've got, some kind of a multiplication. So in this case, we want to use the multiplicative inverse property. So in this case, if we look at the multiplicative inverse property, it says that if you've got some rational number a over b, there exists a rational number b over a, namely its reciprocal, that if you multiply a over b times b over a, gives us a 1 in this case. So again, that's what we would want to do in a situation like this. So if I've got 2/3 x equals 3/4, again, my goal is I want to get x by itself. So I somehow need to get rid of that 2/3. So by this multiplicative inverse rule, if I take and multiply both sides by its reciprocal, then that's going to allow the 3's and the 2's to cancel out, which is just going to give me an x. And then from here, now I can just multiply straight across the top, straight across the bottom. 3 times 3 is 9. 4 times 2 is 8. So it looks like my final answer then would be x equals 9 over 8. All right, so at this point, pause the video. You guys work on practice 4. So if there's any of them you get stuck on, or if you need further clarification on how to do any of them, just let me know. And like I said, I can expand on what I did there. And so when you're done, then come back and we want to talk about ordering rational numbers on a number line. All right, so finally, last thing we want to talk about in this section is ordering rational numbers. And so really the key to this is, because it's kind of hard when you look at these guys, to figure out exactly, which one's the smallest, which one's the biggest, which one goes to the left, which one goes to the right, mostly because the denominators are all over the place. So you might be able to label some of them and get some of them pretty close or pretty close to right. But really the main thing that we want to do whenever we're doing ordering of rational numbers is get that common denominator first. Because first off, that's going to allow us to break this number line up in such a way that it's going to be easy to plot points, and it's also going to be easy for us to actually figure out whether one number is smaller than bigger than another. Because if we know that all the denominators are the same, then really you can just ignore the denominators, and we're really just ordering the numerators in that case. So that's kind of the nice thing. So the key to this is get, or rewrite each fraction with common denominators first. Then once you've got your common denominators, then plot each fraction, and then from there the order will just fall out. So, and then from here order will just fall out, because then we can just read them left to right to see which one is smallest to largest in that case. So again, I'll let you guys work on this just to see how you do. But again, if you get stuck or have any questions or anything like that, feel free to let me know. So otherwise, the exam is on next class. So if you're on the Monday, Wednesday class, it'll be on Monday. If you're in the Tuesday, Thursday class, it'll be on Tuesday. So again, if you have any questions or if you're struggling, anything like that, just let me know. And otherwise, I will see you guys tomorrow in class. So good luck.